You know the saying, you're just a number? Well, out there in the real world, a number is really never just a number. It carries this heavy, mundane message that kind of defines us within the system. You aren't just a person anymore. You're a data point. Take your roll number, for instance. It's one of the very first numbers assigned to you in life. And it just coldly identifies you, right? Slotting you in as just another cog in this massive class register system. You're basically boxed into a grid before you even realize what's happening. Man, even your very existence is time-stamped by your date of birth. Literally from the moment you arrive on this planet, your entry into the world is completely categorized by a rigid string of digits. Okay, let's pivot away from that melancholic reality for a second, because this is where things actually get really good. While we're dealing with all that, behind our backs, numbers are secretly playing games. It's absolutely fascinating. When we aren't actively watching them, these mundane digits are busy forming incredible hidden patterns. It's literal magic. Let me show you exactly what I mean. Start with a completely random, totally boring number, say 34. Now simply reverse those digits to make 43. Add them together. 34 plus 43 equals 77. Boom. Just like that, we've instantly created a palindrome, a number that reads the exact same backwards and forwards. These super simple rules create instant magic right out of thin air. But here's the catch. Sometimes you have to keep reversing and adding. Because while 34 works perfectly on the very first try, you're definitely going to run into stubborn numbers, like 19. If you reverse 19 to 91 and add them, you get 110. Obviously not a palindrome. So it forces you to keep going, reversing and adding, bouncing back and forth through multiple rounds until the magic finally clicks into place. Now, let's see how this builds into something even more mysterious. Have you ever heard of the Kaprekar constant? It's 6174. The brilliant Indian mathematician Dr. Kaprekar discovered this very specific 4-digit number, and it acts like this inescapable mathematical trap. Let's watch this trap in action. Just pick almost any 4-digit number with mixed digits. Let's go with 3524. First, arrange those digits to form the greatest possible number, which is 5432, and then subtract the smallest possible arrangement, 2345. Your result is 3087. Now, you simply repeat the process with that new number. You can literally watch as the math mysteriously pulls us deeper and deeper in. Because eventually, no matter what, your subtraction will result in exactly 6174. And the most magical part, if you try to apply the rule to 6174, arranging its digits greatest to smallest and subtracting, it stubbornly returns right back to itself. 7641 minus 1467 equals 6174. You are permanently stuck in the loop. There's no escape. But numbers don't just create neat little tricks. Sometimes they create massive, world-class headaches. Enter an unsolved mystery known as the Collatz Conjecture. This is a puzzle so deceptively tricky that even the world's most powerful supercomputers get completely stuck trying to solve it. The crucial, absolutely mind-bending question here is this. Take any number, will you always eventually land on 1? The rules to test this out are surprisingly simple. If the number you pick is even, you just divide it by 2. If it's odd, you multiply it by 3 and add 1. That's literally it. Just look at the chaotic journey of the number 6. 6 is even, so we divide by 2 to get 3. 3 is odd, so we multiply by 3 and add 1, shooting us all the way up to 10. Then it becomes 5, spikes to 16, drops to 8, then 4, 2, and finally, inevitably, it crashes down to 1. It bounces violently up and down, but it always hits the floor. Tested on trillions, proven on none. I mean, that is the deadpan punchline of modern mathematics right there. Despite checking trillions of numbers with computers and watching every single one of them eventually hit 1, no human being has ever been able to mathematically prove that this will happen for every possible number. It remains an infinite, beautiful mystery. All right, let's step out of the abstract void for a second and get back to reality, surviving the real world with mental math. We really need to return to the practical reality of dealing with huge numbers, giant advertising sales, and basically just calculating your way through the day without losing your mind. So here's a little secret for you. Great mathematicians, they do not suffer through long, painful calculations in their heads. They just don't have time for that. Instead, they rely on beautifully lazy, clever shortcuts to survive the daily numerical grind. Take the long way versus a super handy technique called round and adjust. If you need to add 456 and 298, please don't stack them in your head. Just round 298 up to a friendly 300. Add that to 456 to easily get 756, and then simply adjust it by subtracting the 2 you borrowed. Boom, 754. It completely eliminates all that painful mental effort. Another incredible survival tactic is to break into parts. Sure, 27 times 4 looks a little intimidating at first glance, but if you break it down into friendly 10s and 1s, it's an absolute breeze. 20 times 4 is 80. 7 times 4 is 28. Add 80 and 28 together, and you get 108. See? It makes multiplication feel totally effortless. Oh, and then there's same gap subtraction. Say you need to solve 82 minus 47. If you just add 3 to both of those numbers, the equation becomes 85 minus 50. The distance between the numbers magically stays absolutely identical, but the subtraction itself becomes incredibly easy to do in your head. The answer is obviously 35. And of course, we can't forget simple estimation. Now, estimation isn't about being perfectly precise. It's just a smart, quick guess. It is an absolutely vital mental skill when you just need a close enough answer to navigate a situation quickly. So why estimate? Well, we use it for checking bills. Making sure a store's bold 70% off advertisement isn't just a sneaky trick when you reach the register. We use it for guessing travel time, rapidly spotting mistakes in calculations, or even just planning how many chairs we're going to need for an event. It's everyday survival. Because ultimately, every number has a story to tell us. The more you practice spotting these rules in the mundane, everyday systems that we started this explainer with, the more hidden magic you're going to be able to unlock. Which brings us to one final question for you. What hidden patterns will you find in the numbers around you today? I really challenge you to look at these supposedly boring digits in your own life with a completely renewed sense of wonder.